Hornets, thank you for joining me today. Today we're taking a look at, once again, reviewing trig functions and solving. So I have some problems again today for students to work on. You'll notice we are trying to give answers to 4 decimal places when we are using our inverse trig and our calculator. So please make sure you have a calculator with you for those of you who are following along. You'll notice in our first question we are trying to find the cosine of theta. It has a negative ratio of 3/4, and we know that cosine is negative, being an x value in the second and third quadrant. We also know that when we use our calculator, using the arc cosine is going to be giving us an answer in the first quadrant and as a negative in the second quadrant. As a result, we will be able to get our first answer simply by using our calculator. And you'll notice there is no mode. We also don't have a domain. So we'll be looking at all solutions that we can possibly find. If, however, we had a domain, I believe on the answer key that I provided, I did not put plus 2 pi k or plus 180 degrees. I also did mine in radian mode. So please make sure that you are in radian mode. You click mode, go down to radian, and make sure that the black box is on radian. Thank you. So when we do this, we are just going to be putting in second function cosine of negative 3 divided by 4, or negative 0.75. We expect to get an answer in the second quadrant, which means it will be over 1.5, yet about 1.57. We also know that it's going to be less than 3.14. Notice that this is indeed within that parameter between 1.57 and less than 1.34. So our first answer, as we're going to write it in radian mode, is theta 1 is approximately 2.4188, and I have truncated my value. Now remember, this is only giving us theta, and if we are looking for our reference angle, we need to make sure that we take this away from pi. So if you have pi minus this answer, you will be able to find your theta prime, and our theta prime turns out to be approximately 0.7227. Now, in order for us to find our second answer in the third quadrant, all we have to do to the cosine is take our answer away from 2 pi. So if we are to do that, I'm just going to do 2 pi minus the answer. And I will find the second answer between pi and 3 pi over 2 pi over 3, 3 pi over 2, excuse me. So I have 3.8643. Now, please keep in mind what we're actively doing is we are taking our arc. We want to find the reference angle, which means I'm going to go pi minus the arc cosine of this negative 3/4. And then when I have that answer, I'm going to add it to pi. Remember, this is giving me my reference angle here, and from that, I'm able to add it to pi to find the answer in the third quadrant. Now, notice right here, here's the 2 pi that we are adding and saying 2 pi minus our answer. Gives us a quick way of finding our cosine solutions regardless of what value we get. If, however, we had a positive, for example, we'd know that we would get our reference angle immediately, and to find it in the fourth quadrant with a positive cosine, we would do 2 pi minus the reference angle. So in any case you look at it, all you have to do is find your answer and subtract it from 2 pi. Now, because we do not have a range, I am going to go ahead and I'm going to add plus 2 pi k in order to give me all of my sequence of values around and around and around with an infinite number of coterminals. Number 2. Notice in number 2, this can be written as a quadratic, and we do have choices. I can either use a dummy variable and say let's have u equal the tangent of theta, which will allow me to break this up into 3u squared minus 2u minus 1 equaling 0. and from this I can factor. I know that I have to have 3u times u in order to have a 3u squared. I know in order to get a 1, I'm going to have a 1 in back. I just need to make sure that I can get a negative 2u and a negative 1 product. That means that one of them is going to be a positive in between, and one will be a negative. This comes back to our Algebra 2 and our Algebra 1 that you probably had several years ago. So I'm going to make sure that I have a negative so that my 3u is a minus 3u. I'm going to put a plus 1 right here so that I have a positive u. Once I have that, I can now back substitute my tangent of theta for u. Please remember this is only an option. It is not required. Many people, as you get more and more used to your trigonometry, are going to be able to factor it completely and simply go to 3 tangent of theta with a 1 and then have tangent of theta with a 1 equaling 0. And the same concept applies. I need to have a negative 1 multiplied by the 3 tangent of theta so that I have a negative 3 tangent of theta and add a single tangent of theta. Notice at this point both are now congruent or equal. They match, they concur, and I'm now going to set each piece equal to 0. Tangent of theta plus 1 should equal 0, and the tangent of theta minus 1 is equal to 0. This is giving me the tangent of theta is equal to negative 1 over 3, and the second one says that the tangent of theta is equal to 1. Notice that we are changing our mode from radian into degree, so when you turn it on, please hit mode and go down to radian, move over to degree, and hit enter so that the black box is on degree. We can now do the second function, tangent, and I'm going to put negative 1 divided by 3. Notice that I get a negative reference angle. We know this is going to happen. This is because in our arctangent has 2 asymptotes that are horizontal, and our curve goes in between them. It will never reach pi over 2, as it is a horizontal limit at infinity, and it will never reach negative pi over 2, as it will only reach it at negative infinity. So our answer is going to be either the first quadrant, a reference angle, or in the opposite of the first quadrant, our negative reference angle. It can never be greater than pi over 2, and it can never be less than negative pi over 2. So when I get my first answer in degree mode, I'm looking at my reference angle's opposite. And so I know that my reference angle is 18.4349, and this is in degrees. Now, in order for me to find my 2 solutions in the second and fourth quadrant, I'm going to be taking this reference angle, theta prime, and first subtracting it from 180 degrees, and then subtracting it from 360. This will give me quadrant 2 and quadrant 4 respectively. So as we do this, I'm going to do 180. If you wish to see, I'll put it right here. 180 minus, in this case, I'm going to go ahead and use a plus because I'm going to be using that negative answer. Notice that's the same thing as 180 minus the reference angle. I get 161.5650, and I'm going to put that down as my first answer. This is theta 1, 161.5650 degrees. I'm now going to repeat the process, but this time I'm going to be using 360. So, going back to my arctangent of negative 1/3 to get my answer, and then doing 360 plus my opposite of the reference angle. Excuse me, let's try that again. So 360 and then plus my answer. I put that in and I get 341.5650. And this is my second answer. Theta 2 is approximately 341.5650 0.5650 degrees. Once again, I have truncated. Now, in order to figure out when tangent is equal to 1, we know this is when our sine and our cosine are congruent. Sine and cosine, or equivalent. Sine and cosine will be equivalent at a reference angle of 45 degrees, and therefore in the first quadrant, my answer, and this will now be my third solution, is going to be 45 degrees. Going into my third quadrant, where the tangent is also positive, this is going to be my fourth solution, and this will be 225 degrees. Notice that these two are exact, whereas these two are approximations because of their decimal place being irrational. I'm now going to go to number 3. Now in number 3, we have the best option is for us to move the cotangent theta, cosecant theta to the other side so that I have positive values with the largest coefficient. 2 cotangent of theta minus cotan of theta cosecant of theta. We're also changing our mode into radian mode, so I'm going to do that first. Changing into radian mode, and now I can factor out the cotangent so that theta 0 equals the cotangent of theta times 2 minus the cosecant of theta. Now I know the cotangent is going to be equal to 0 at pi over 2 and 3 pi over 2, and they are 180 degrees apart. So we first find when is cotangent of theta equal to 0, and once again this is pi over 2, and we have 3 pi over 2. If we were in degree mode, I would be saying 90 degrees and 270 degrees. To find the second part, we're going to set 2 minus cosecant of theta equal to 0. And I'm going to move the cosecant so that I keep positive values. I now have 2 equals the cosecant of theta. If you wish to flip it around, you may, so that the cosecant of theta is 2. And we know that this is going to happen when sine is 1/2. We know sine is 1/2 at pi over 6. And we know that sine is 1/2 at 5 pi over 6 in the second quadrant. These are now my answers. And once again, we do have a restricted domain from 0 to 2 pi, and these are the only values that we'll be able to find in that domain. The last question that we had today in our class is working with now a fractional coefficient as opposed to a integer coefficient, or as we've been doing, whole number coefficients. So once again, you have the choice. I do like to have my alpha equaling 1/2 of theta, and therefore I'm looking for when is the cosine of alpha equal to root 3 over 2. This is going to happen in our first and our fourth quadrant. We know the reference angle will be in radian mode, pi over 6. So my first answer is going to be pi over 6, and I'm making sure that I add plus 2 pi k. I'm then going to go ahead and I'm going to find the second one. Now the second one is in the fourth quadrant, and that is 11 pi over 6 plus 2 pi k. I'm now going to put in 1/2 of theta, 1/2 of theta, and in both cases they equal each of these pieces. Notice that I'm going to now multiply everything by a 2, so that I find that theta is going to be pi over 3 plus 4 pi over k. The other one will be theta equals 11 pi over 3 plus 4 pi over k, or 4 pi k. Now notice, I'm going to want to get thirds so I can see how many solutions I can actually find. And I'm going to change this from 0.6 pi into 0.18 pi over 3. I'm now going to keep adding 4 pi until I end up with values that are beyond that. Now, in order to figure out what 4 pi k is in terms of thirds, I'm going to multiply the numerator and the denominator by 3, and you'll notice I'll be adding 12 thirds pi. So my first answer is pi over 3. When I add 12 to it, I end up with 13 pi over 3. And if I add another 12 to it, I will have 25 pi over 3, which is outside of the domain. These are my only two solutions for this problem. To find the last one, I'm going to do 11 pi over 3. It is still less than 18 pi over 3, but if I add 12 pi over 3 to it, I will end up with a 23 pi over 3, and that's too much. So these are my only solutions within the domain given, and I can stop. Once again, you barely see that. I'm sorry about that. I hope that didn't confuse you too much. If it did, please forgive me. But let me just review it again for those of you who got kind of lost. Sorry for that interruption. So please keep in mind that once I find my pi over 6 and my 11 pi over 6, I'm still adding my rotations of periods, and the period for a cosine, just as like a sine, a secant or cosecant, is 2 pi k. So I have 1/2 theta equals pi over 6 plus 2 pi k, and 1/2 theta equals 11 pi over 6 plus 2 pi k. When I multiply everything by 2, I get theta equals pi over 6 plus 4 pi k, and 11 pi over 3 plus 4 pi k, and theta equals 11 pi over 3 plus 4 pi k. Now when I add, I make sure that I add the 12 pi k thirds, and when I do so, I end up with pi over 3 plus 12 pi over 3, and I end up with 13 pi over 3. I start at 11 pi over 3, that's my first answer, but if I add the 12 pi over 3, I end up going outside of my domain, and I have to not accept it. Therefore, my only answers to number 4 are pi over 3, 13 pi over 3, and 11 pi over 3. Thank you for your patience. I hope this has been helpful. If it has, please remember to click like, and if it hasn't and you have suggestions, please let me know and I will try to improve. That is the word of the day, improve. I am trying to improve the way I teach and the way I respond to people. I hope this is helping you. Thank you very much, Hornets. Take care and have a good night. Bye-bye.